So in today's video I'm going to do some work on this Ender 3 V2 printer. I've got the bits scattered over the desk already. This is the Z-axis upgrade kit. So you actually put on a second Z-axis, which means you've got one driving each side of the gantry, which is much more precise. So this kit comes with a stepper motor, a new lead screw, coupling, bracket for the stepper motor, new gantry bracket for the lead screw, various bolts and nuts and stuff which are needed. You've got some guides at the top which fit on the top of the lead screws to help hold them upright and vertical, so the top of the screw doesn't go like this and wobble. Might actually be helpful, I don't know. Depends how straight your lead screw is, I suppose. We've got a replacement cable here for the motors. So there's a dual plug there which splits off. And there's a bracket here which isn't used on this particular printer. This is the V2. This bracket's only used on the original Ender 3, I believe. And it has some instructions which are extremely brief. So here it shows the power supply being mounted with that bracket there. You see this? In this case, power supply is on the bottom of the casing, so it doesn't actually need this. So this is for the original Ender 3 version, which this bit's all the same, this will be the same, that bit there is different. And there's some instructions on the back there. Now we're going to ignore these instructions. We don't need no instructions.
PCBWay are doing their usual thing. They're doing a little sale at Christmas time. This ends on the 31st of December. PCBWay sponsor my videos from time to time. When I want a new PCB made, they will make it for me and supply it to me at no cost. They've always been really happy with the service. And they do all sorts of things now, 3D printing and CNC machining as well as PCBs. So definitely check out their Christmas special. If you want to get some PCBs made or some 3D printing done or some CNC machining done or something like that, go and check them out.
So here's the end of the box. You can see it's called the Ender 3 Dual Screw Rod Upgrade Kit. So this is the rear of the printer. Now we've got to do the mounts over here. So this section here is where they mount the stepper motor, just like so. We've got to take this apart and put on this bracket here. That'll fit over there. We've got some replacement screws we have to put in there. Now when we actually do this, we're going to have to do a few changes. One thing I'm always fussy about is alignment. Mechanical alignment on anything requires care and precision. When you put everything together, do not tighten everything up when you assemble it. There's a reason for this. So when you actually put things on, like the stepper motor screws, the bracket for the stepper motor, this bracket, these top guides, when you put all those things on, put them in place and just nip them a little bit so it's just enough to hold it in place. Because what will happen is you will get misalignments in things. And in order to make sure that those misalignments don't cause problems, you need everything to self-align. Now things like the carriage distance as well, between the lead screw distance, like here to here, when you get the other lead screw fitted, which will be up there like that. Things like that, you need to be careful of as well. Like you might find that your lead screws over here, they're one distance at the bottom and a different distance at the top. Right? And obviously you need to make sure that they're not fighting each other or anything like that. So you have to basically have everything a little bit loose so it can all just settle down. Even just with the single lead screw on this one, when I first assembled this printer, I noticed that there's actually a misalignment. Yeah, I mean, this lead screw actually leans over very slightly, and that's where it naturally wants to sit, which is interesting. So I've organised all the nuts and stuff here. Now we've got these screws here, which I think we're not using because these are used for the other bracket for remounting the power supply. I don't see any use for these. Move them out of the way. We've got T-nuts. We've got some longish screws here and some countersunk screws. These will be used for mounting the stepper motor. We've got spacers, 3 longer bolts which will be used for the gantry and that bracket. And we've got 4 screws here which will be used for the Z screw alignment bits up the top there. Okay, so that's all really straightforward. Without needing to read the instructions, we can actually figure out what we need to do without much trouble. So the first thing I'll do is mount this onto the stepper motor. Put this stepper motor sideways like this and have the cable come straight across, or you put it facing backwards and have it looping around. I'm not quite sure how I'm going to mount this yet. I think I'm inclined to run it backwards and that will give me some guidance for cable management. This comes right back to here. Don't forget, this allows movement of this without getting caught up. It may be better to bring it down here in that gap and run it across to here. I'm not sure yet. I might have to adjust this later on. But anyway, so we'll just put these in here for now. Again, I'm not going to tighten anything yet. I'm just going to put everything in place roughly right, so it's just got a little bit of tension on the screws so I can move around slightly if it needs to. That's those. Countersunk screws, one of which is now on the floor of doom. That will go through there like that. Okay, let's get the other one, which I dropped on the floor. So I've got this T-nuts, so I'm going to put this on. Just a couple of threads, get it started off so it doesn't fall off. Like that. Now these, you line them so that, like that, not sideways, that way. Then you can push them straight into the channel. As you turn them, they'll turn like this, as long as there's no tension on them. They'll spin within the channel, sit that way around, and then they'll tighten up. So they're both dropped in. Maybe you can see it spin on video, I'm not sure. So I can get the screwdriver in. Come on, spin, spin, spin. There we go, that's turned. It's starting to go in. Do the same with this one. Come on. It's easier to use one of these than it is to use an actual Allen key. So let's just get those in. And slightly tension again, not doing everything up tight yet. Okay, so it's got some movement in there. See, it'll move slightly. We want that initially until we get everything fitted. So the next bit I'm going to do is fit these at the top here. You may think it's a bit weird to put these on now. We haven't got the gantry part done yet. Well, that's because then we can just drop the lead screw through this and get it all aligned that way. Otherwise, once you put the lead screw in place, you've got to try and like move it out so you get the thing in there with the studs and everything. So these T-nuts you've got to get into the slot, don't forget. I mean, you don't need bend in the lead screw. Now obviously we've got the lead screw already in this side. It's not ideal. Put these in first and then we'll do the gantry. So here's the screws. We'll drop those through there. And again, it's got to put T-nuts on. I'm pretty sure it's this size screwdriver. So these are 2mm or 2.5mm heads on these screws. Hexagonals. I think that's actually a 2.5, not a 2. These are 2.5mm. The ones I did before, these ones here are 2mm. Those ones there are 2.5. Again, we'll just get it on there, a couple of threads. Right. So I'll prepare both of these. Okay, now I can slot this onto the gantry. Right, so now to make sure this is all lined up, so you can see they've got the nuts sideways, so you can drop it straight into the channel. Just like that. Now we've got to actually turn these, obviously, like I said before, we've got to make sure that these will spin and lock into the channel. Now, I'm doing the back one first because I can't see that one. That's obviously locked in now because it's not falling off. Now, this one you can see, you should be able to see it turn when I get it actually in there. Well, you can see it's straight. Now I've got it turned. Here we go, it's turned, now I'm going to do it up. Okay. Now, these I will nip so it doesn't just fall off. When we do the lead screw, we'll loosen this off again and make sure it's all aligned nicely. And I'll show you how to do it later on. Now I'm going to do this side. Obviously I've got to bend the lead screw out of the way for this case, so I get it kind of lined up and wiggle it around a little bit and it will drop in. There we go. And we get those nuts wiggled in. That's in. Now I've got to tighten these up. I think that's not turned. That's turned because it's now grabbing. The other one I can look at from the inside. That is turned and that's grabbing. So that's it. So what I'm doing on this side is I'm winding the gantry up. Now I can actually see this is bending over. So I need to loosen this slightly and let this thing align itself. See, there we go, it's self-aligning. I'm going to leave that loose, continue winding the gantry up. And this way, this is going to align this block. Okay, right to the top as far as I can. Now you can see I've got my spool holder mounted on the side because that gives better alignment into the extruder. So let's tighten that up there and tighten this one up here. And that's that side aligned. You always do one side, then the other side, and back to the first side again. Okay, that's that side done. So now that is aligned with this, at least in this direction. It may not be aligned in this direction. We can check for that. This bearing does actually have like a slot that runs inside this casing, and you can actually move it slightly, but you can see it's actually pulled over basically all the way this side. If I can't put it this way, but I can push it that way, which means this is actually slightly out of alignment in this block here, the original mounting for the nut which is on this bracket. So what I'm actually going to do is loosen these screws off and adjust this so it takes a bit of slack off that as well. Oh, it's all trying to fight each other. So let's loosen these off. I've already loosened the front one slightly, so I'll make sure I can actually get into it. That's now loosened there. loosen there, so those are now loose. So this nut will have a little bit of play in that slot there, right? Not much, there's a little bit of play in there. Bring it all the way up as far as we can and give it a chance to align itself. Alright, so that's now got some movement in it, you see that now? A lot more movement. So I want to try and get that more centered, then over to one side. And we'll just do this one up because we can get to that. That should be enough to lock it in place. Alright. And that's now got free play just there, it's actually floating slightly. Doesn't want to pull this way still, but it's now actually feeling free, it's not feeling like it's being held there. So that's better. So now we can do the other screw up and that'll be that one done. Alignment stuff's very important. Now because I made that adjustment to this nut here, I need to make sure this bottom bracket here is all nicely aligned as well, because it may have affected the stepper motor alignment. So let's loosen these off slightly. Let that self-align, let it wobble around a little bit, so it wants to sit there where it wants to sit there, and then we'll tighten it back up. Don't forget I've got the gantry right at the bottom here, it's basically the nozzle touching the bed. So that is now self-aligned down here as well, and that should be good. Make sure those are nice and tight. And we'll basically repeat that process for the other side really. Right, now we're at the next point where we do the gantry part. So what size screw is this? It is the 2.5 and it's not that one. Okay, need a bigger one, must be a 3. Right, so yes, it is a 3mm. Just like that. So I've also got a nut driver here, which is an 8mm nut driver. It's close enough, it's slightly loose. That's right. Now you need to retain most of this stuff, or you're doing really changing the bolt and putting another spacer on. You have to change this bolt and put another spacer on. These are long bolts. What the Montez M5 by 40. And also you've got the spacers. So, bolt, spacer, wheel. Mine aren't worn, so if yours had a bit of use, you might want to change these out now once you've got it apart. But mine are fine, I don't need to do anything with that. Spacer. Okay, so that's basically how you're going to sandwich it up. Obviously we're going to do it on a bracket. So in this case I'm going to put the bottom screw in. So I'm going to just bottom screw the bracket like this. And then the spacer, and the wheel, and the spacer. And then put that through there and put the nut on. Right? Make sure I've got the right hole. That'll spin around to like that. It will. Just like that, okay? Again, just loose enough to have a bit of play in it. And now we'll take this one off, because obviously I can't spin this around until this is out of the way. We also have to get this bolt out of here. We'll take these screws out to take this bracket off this gantry as well. Take this screw out here. And that should come down like this. 3mm nut drive on this side. I'll get this one off. Now this has got the eccentric nut on this one. You have to make sure you put this back in correctly. I'm just going to show you here. So you put the eccentric nut on, it goes into that hole. Right, as you turn the nut, it actually moves the bolt side to side, which is how you adjust the wheel tension. So we've got that. We have a spacer, and obviously then we have to put the plate around. So now we put this back on. Oh, lost it all. Anyway. Slide the bolt back a bit, bring it down. we go, that's there. Put the nut on. Okay. There's a hole just here which allows you to put the screwdriver through, or the Allen key, to get to that screw there to do it up. Anyway, let's do this up. It's nice and tight. We'll pop that back up there. Put these screws back in again. Not tightened yet. Let's get that into the gantry. Tighten it up. All these have to be really tight. Don't forget, this is what's controlling your nozzle alignment in a way. These two screws. So if these are loose, this will flop around a little bit on this beam, and you don't want that either. So you have to make sure you're nice and tight. I'm going to go through from this side, this case, because it's looking nicer. Now it doesn't actually matter which side the bolt comes from. I should probably thought about that for this one. I might change it if it bothers me enough. Put the wheel in there. Then we need another spacer, which I can hopefully get in there without dropping it. I might need tweezers, hold on. Okay. Go in there somewhere. I might find the eccentric nut is in the wrong place, so I want a bit of tightness in. It's looking that way. Let's get a spanner to sort that out. So I loosen off this nut here, with that whole thing, because you can actually get to it from the other side anyway with a Allen key or something. So I could adjust the eccentric nut. This is now just about going through there. Here we go. Put this nut on. So these two we can definitely tighten up now. This one we will do again once we get the tension set. So it's not too big a deal. 3mm. You want these ones to not move around at all. That's that one. Now this one, so I've loosened this off slightly so I can actually move around now, so I can get the tension set. I think I've probably got a little bit too loose right now, maybe. Yeah, maybe not. That's probably alright actually. Got a little bit of tension on there, maybe not quite enough. Slightly more tension. Now let's adjust the roller tension, so kind of make sure it's sitting where it's supposed to sit, and then you can see if any of these spin. This one spins fairly easily, that one's loose, so we need to adjust this to get some more tension on that until this one stops spinning. Maybe I need to loosen this off a bit, let it move, let it self-align in that position. Let's do that. And the same here. These two being different, so I don't know normally now. Alright. Still nothing there. That will not tension up. So tension it all the way up. That's tight on there. That's alright. I mean, these two are locking against each other, but you want tension across here. So what's actually happening here is, as I'm tensioning this, it's pushing against that side of the frame, so it's trying to pull it this way, which means it can't pull this one onto the frame there. Let's do this. Let's loosen this off. Maybe the whole thing is tipped slightly. And that's making it then force between these two and not that one. Okay, we'll have to readjust to these tensions and it will self-set, but that's fine. I've got these ones basically lined up now. I've got to re-tension this side. Now this bracket isn't pivoting, it's sitting better. There you go, I've got tension on that one there. That's much better. Yep, that's about right now. That's much better. So tighten these right up. I was just a bit premature about tightening these up the very first time. Yeah, got tension, that's all good. That's actually about right, I don't have to adjust it. That's the tension set. So now we've got to put the coupler on this, so we've got two ends, big end, small end. Small end will go on there like that. What I'm going to do, you have to have a gap. And if you actually look, I don't know, you probably can't see it, but as the shaft comes up through the coupler, you see from this height here effectively, it'll come up so far into it. Now you need to make sure it doesn't come up too high. So it actually says it's supposed to have like a 5mm gap. Now this is a 5mm bolt, so let's just shove the 5mm bolt across there, and that'll give us the gap we want. So let's just do the coupler up like this. Now again, I'm not going to tighten it right up, just enough to take tension on. Right, so that's in there, just enough to hold it in place. You can see it's still loose, we haven't tightened it up yet. Now we can put the lead screw in. Drop it through the top bearing, and then screw it through this. We'll screw it through this, he says it doesn't go. That doesn't want to go. Let's turn the lead screw around, maybe it's got an issue with thread damage. That does not want to screw through the nut. Why does that not want to screw through the nut? Let's just force it through, there we go, it's going now. Now that's still really tight right now, that's no good, we don't want it tight. Yeah, that's fun. So I thought let's check something here. Let's check if that's actually a right angle or not. Let's bring this down. I don't think you can see it on camera, probably not. This bracket isn't quite pressed right, it's at a very slight angle. So I've got this ruler positioned here now, you can see the gap there. Just there, see that gap? This bracket isn't at a right angle like it needs to be. If there's at a right angle, that'd be better. So I'm going to adjust this bracket slightly. So I've just adjusted that bracket a little bit. Let's try it again. My torch is going to work nicely. Much more straightness there. It's still got a little bit of a gap just there actually. Still a very slight gap. I took the lead screw out as well obviously. But yeah, that's looking a lot better. I think the bracket's slightly curved. Let's put the lead screw back in. That's much looser. That's much better. Now, as I'm getting into the base, let's zoom out slightly. I'm getting into here. You see it's misaligned. So it's aligned at the top, obviously, where the mount is at the top, the alignment piece. This is here, and then look at the stepper motor here. This is going into that. Look at that gap there. You can see as it's winding down, see it's actually missing the hole quite a bit, and as it comes over, see that? It's actually pushing backwards into the stepper motor. Right, so that's going to be fighting itself, which means we need to loosen these screws off here and try and get this nut to slide backwards a little bit. Right, so loosen the screws off and just give it a bit of a pull to try and move it. Then you can see now it's basically, that will drop straight in. Alright, no trouble at all. Now obviously we need to tighten everything up. So that's in there. So the first thing I'll do is tighten up the stepper motor. This will then align to the stepper motor. And then we'll bring it all the way to the top and align the top bracket to this bracket. That should all then be dead straight. So that's fully down. Let's tighten these ones first. Then we'll tighten these ones up. Again, and again. We'll always do it twice. Right, now let's check this screw alignment again. Now I've adjusted that. But it's still pushing over slightly. Give it some more. And this bracket's not the best formed. There we go, it's now going straight in. Like that, it's going straight in there. No worries at all. Okay, so let's tighten these up with the correct bit. Right. That's tightly in there. That's down. Let's tighten up these. So that's where it's supposed to be now. It's not the easiest ones to get into with this. Allen keys probably would be better for this particular job. Right, they're tight. Now we wind it all the way to the top and adjust the top one. That's all the way to the top. Let's loosen these off a little bit. Just a little bit. That's pulled over, I felt it move. And alignment in this direction, that way, is good. It's sitting right in the middle. So that's sitting exactly where it wants to sit. All nice and straight. So that's all self-aligned and tight. Nothing's fighting each other. That's exactly what we want. Now the other thing we should check is these to make sure they're still okay at the top of the frame. Yeah, they seem alright. They've got about the right amount of tension on them all. So what can happen with these frames when they're first assembled, or when you first assemble it, whichever way it goes, there is a bit of tolerance in this vertical beam. So when you put these top screws in to attach this top beam to the vertical ones, you could just put them in and go, oh yeah, okay, it's all good. But actually we can actually get some misalignment there. So what I actually suggest you do when you do this alignment is obviously when you have the gantry right at the bottom, you adjust all the tensions and stuff like that, do the bottom bolts up, bring it all the way to the top, then do these ones up afterwards. I'm trying to recall. So when you bring it up to the top, then loosen these and then retighten them. That way it realigns these vertical ones to the gantry, which has been set to the bottom. Right? You know what I mean? So you've got the gantry set up at the bottom, you then tension up these bottom bolts, you bring it up to the top, you have these loose, you then tension those up, and that then sets the vertical alignment of these with your gantry width. Right? That way keeps it dead parallel. So all we've got to do now is do the electrics, which should be straightforward. So we've got some protection sleeving here, we should use that, and we've also got the actual wire here. So one end will go into the control box, probably this one, then you've got the ones that split off. Could be either way. I think this one here will go to the control box. They're all marked as Z, so it's pretty useless really, but anyway, yeah, it just says Z, 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 so I don't think it matters as long as one goes to this motor, one goes to this motor, one goes to the control box. I think the control box one and this one are the same, yeah, they're basically the same length anyway, so that should actually matter. You can't really get that wrong. Now, this one's got to be unplugged. That's the original Z wire. This one needs to be plugged in. Now I have to run this cable here across to this motor. So I'm probably going to attach it to these cables over here and run it around the back in some way, which is then controlled. So yes, having it coming straight out the back of that motor, having it coming straight out the back of there was definitely the better idea. So it can come straight out like this and then around the back of the printer. Okay, so I'm still going to put sleeving on it though, because why not? You should always put protection sleeving on things, stop things wearing. Now this stuff is a bit of a trick to it. You think, how do you get this through here? Well, the trick is to just push it. As you push it, it expands. See? And then you can get it in there. And then once it's in, you just keep pushing, basically. Right. And it will just expand around it. Yeah, it's a bit fiddly, but yeah, that's why Creality didn't do it. Why pay someone in the factory to do it when you can do it yourself? Anyway, yeah, just basically just pushing it through, and it's kind of getting stuck there. Giving it a push there, right? Keep pushing it. Getting to the point now where it's going to bind up. Of course it is. That's fine. You can just do this. What I'm doing is basically getting this, pushing it down to where the connector is, grabbing on the connector, and pulling this piece down. That's working it through. Right. And we're just about there. The end bit's being difficult. There we go. There you go. We're through. Slide this down. We've got a twist in there somewhere, have we? Get the twist out of it. So I will cable tie this over here somehow and get this all nicely done. So this pulls forward to like this and comes back to here. Make sure it's not going to get bound up. Or could bring it around this way, I'm not sure yet. Bring it around that way might be better. I shall route all these around, tidy it up, then we'll do the cabinet part. So I think something that's bothering me a little bit here is that there's just too much wire, right? So this is the one that comes from that stepper motor. I mean, obviously I've got the printer tipped up now to get to the bottom of it. This is the wire it's going to feed in. This is the looms that come into the controller over here. I'm going to bring it around underneath and run it through here, right? So it goes straight into the cabinet. But there's just too much wire. I mean, the wires could have been that one there, probably half that long. You know, cut that much off it. I don't know, what's that, 20 centimetres, 30 centimetres maybe? Yeah, I don't know, cut 20 centimetres off this one. You could cut 20 centimetres off this one and it'd still be fine. I'm just surprised the wires are this long, because now there's a lot of cable management issues you have to deal with. So I've done the cable management stuff, I'll show you in a minute. So you've got to take this screw here out, which is 2mm. Then we'll flip it over, take the bottom casing off as well. So this is basically a cable management I've come up with. I've cable tied it onto the side here of the original loom, and just like done it sideways facing and bundled it up. And I also cable tied it over here at the back there to try and get this out of the way. When it's sitting on the foot, this will actually compress down. It'll be fine. This will be out of the way. That's just that sleeving really. So that'll just be popped down. That'll be okay. Won't be resting on that much. Mostly be on the foot still, so it's still okay. So all good now is put this cable through into the box, and we've just got to take a few screws out. There's a long screw. The other ones are short screws. Right, so this should now come off. Be careful because there's a fan attached to it, like that. So don't just yank it off. There's the outputs for the various stepper motors. This one here is the Z motor. So that's what I've got to pull out. Might be gunked in, I think it is gunked in. We've got hot glue in it so it doesn't just fall out by itself, which is I suppose a good thing for manufacturing. But now we've got to get that off. There we go. There we go. Right, there's the Z, which pops up over here. We're going to take that wire completely out because right now don't forget it's still hanging out the side of the cabinet. It's running through there, and we've got to try and get it out of there somehow. Anyway, we want to thread this one through and plug that one in. So we'll bring this around the back of this stuff here. And then we'll give it a turn, and it's got to go in the other way up. So it's got to go that way like that. Okay. Give it a push, give it straight. That's in there nicely. And if you want to do this as well as Creality did, you put something on it to make sure it doesn't drop out. But it's not likely to happen. So we've got all this cable here. We need to then kind of manage it into there. That should just sit nicely there, I think actually. That'll be right. So now we've got to try and get this cable out. I've taken these two screws out the front here. There's two like this. Taking both of those out, that gives us a bit of wiggle room on the controller. Now the controller has actually just got like a join here which runs up the side. So what I think I can actually do is slide this cable up that gap. Get a great gap, there you go, and slide it up. And then I can probably pull it through. There we go, there's the wire. So I think once I put it through enough up here, create a big enough gap, I should be able to put it through up here. There we go, easy enough. That wasn't that bad. Put these screws back in again. Right, so now we can put the cover back on, because we should basically be done now. Now it has this lip here to watch out for not pinching anything behind it. Might have to wiggle it backwards and forwards, get it in place. Feels like it's rubbing on something. What's that rubbing on? Get the small screws in first. Again, don't tighten them, just put them in place. Get everything lined up first, then tighten it. I think this long screw is a tricky one because it goes right through into the beam here and it's a bit hard to get lined up. Oh no, straight in, that was lucky. Okay, again not tightening yet, got to put the top screw in yet. Okay, once this one's in I can actually tighten it. This one can be tightened, I'll go through and tighten it the other ones. Okay, tight. Okay, that should be it. So now we've done all this, technically you should just work. There's a couple of things you have to be careful of. Because you're independent drives each side of this gantry, if you have a misalignment, that misalignment will stay misaligned all the way up, all the way down, because they drive by equal amounts. So if you tip this one like this, so you just move up and down, even though I'm holding this side, there is still play there, right? It doesn't get rid of all the play, you still have that alignment issue there, right? It still exists. Or I could do the same this side. Doesn't matter. Obviously got a bit of slop in this nut here, I might have to replace that. It's got a bit of slop in there. But if it's out of alignment, it will continue to be out of alignment because they'll both be going together. So you have to kind of make sure this is horizontal. The other thing you'll be careful of is that if you do raise this up and down manually, sometimes you have to do that. The printer, you know, it's turned off and you want to get the nozzle up so you can, you know, work on something or whatever. You need to turn them both at the same time. Right? And if you do manual adjustment like that, this will easily tip your gantry over and will result in a bed height difference between this side and this side. Previously when it's using a single Z stepper, you're relying on the tensioning of all these and everything to be all nice and tight and taut and holding itself in the line, and it's not perfect anyway. But with this you can actually see easily how much slop is actually in that system. Even though it's been adjusted out in tension, there's still a lot of movement in there. That's the advantage of having the dual Zs. Disadvantage, like I said, is that you have to make sure it stays aligned. And if you try and move it manually, you've got to be careful about the fact it's going to tip it. What I actually think this would be better with, like an additional upgrade, is having these two lead screws tied together. Right now, I do believe there's I haven't seen it. I think someone's mentioned it. I may have even seen it at some point, but I believe there's a alternative to this kind of setup where you just have a belt drive from this lead screw to this lead screw without a stepper motor on it, and so this single stepper is still driving the whole lot, but this one's driving the belt to drive this lead screw, or maybe it's underneath. I don't remember, but I think it might be up the top. If that was added to this, that would keep the two stepper motors in sync with each other. Right, so if it had a link between the two screws, right, you should probably put it up here, maybe have the belt across here, and that would then keep the two motors in sync with each other, because if you turn one lead screw it'd have to turn the other one the same amount. So that's probably another thing to look at, is maybe adding that as well. Right, now we need to actually test the motors, make sure they both work. I don't actually have anything to print right now. This one I do want to print, but I'm not actually ready to do that yet. I haven't designed it. Now what I'm going to do is going to use this ruler here. I do have vernier I could use, but this will be good enough I think. And I'll just check the height. That's about 45.5 there, and here is about the same. So that's basically parallel with the bed right now, which is great. So what I want to do, find the right setting, move the Z axis, I want to increase it. Don't forget negative is going down, positive is going up. So I'm just going to go 2mm right now, okay? See if they both turn. Yep, they're both turned. Excellent. So we'll do it some more. Let's go up to 30. And that's all looking nice. It's all nice and smooth. No funny noises. Okay. Let's go up to 120. Well, actually we had 4.5 on this ruler, didn't we? So if I do 124.5, that should give me about 130 on the ruler. Hopefully. At least I got my maths completely wrong. I did get my maths completely wrong. That's a 170 exactly there. Exactly 170. That's 45, not 4.5. Yeah, and that is also exactly 170. So yeah, that's still parallel all the way up to here so far, and that's good. I mean, this is like the biggest thing I'd ever print. In fact, the biggest thing I print is probably smaller than this. It's probably about down here. So I don't normally go this high with this printer. So as long as it's parallel in this distance, I'm happy with that. But that's looking good. It's looking like it's staying parallel all the way up and down, like it's supposed to. There's no issues with motors slipping or missing steps or something like that. It looks like it's fine. So let's try homing it now from where it is. Make sure that still works. Yep, that's fine. Yep, that's good. I don't have a BL touch or anything here, obviously. I may put one on later on, but I'm actually fairly confident with my bed setup. It's actually pretty good. I get really good consistency out of it, so I don't really want to change it. And at home just fine as well. My setup here I'm actually really happy with. It's going to be even better now I've got this gantry here. It's basically going to be perfect all the time. It's always going to be consistent every time. Now, but what I've got on my bed here, you may have noticed this is a bit different. The Ender 3 V2 comes with a glass bed. I still have the glass bed, but what I've done is I've put on a magnetic bed on top of it. So I put my magnetic sheets. This is a really nice one. This works really well with PETG. It's a 2 trees one. And it's basically stuck the magnetic sheet on top of the glass bed and then lay this down. This means I've got a perfectly flat magnetic bed. And because it's perfectly flat, once I've got the corners set, it works fine. It works beautifully all the time. It's working really well. So I don't feel like I actually need to put a BL touch or anything on this. It works well as it is. So I think that's a nice little trick. If you've got the glass bed and worry about adhesion or getting the parts off the bed, which is the reason I had problems with it, stick a magnetic sheet on the glass bed. It gives you the best of both worlds. It's a bit compromised between weight and stuff like that. You know, you may lose a little bit of speed overall because of the movement of the bed, but it's a small compromise to make, to have a perfectly flat bed with a magnetic base which you can easily get the parts from. This works really well for me. And the only thing I wasn't happy with was this gantry movement here. It was a bit of slop in it. I couldn't get rid of that completely. So having the dual Z now will solve that problem for me. Check out my other videos down below, other 3D printing videos, other upgrades. Did a bunch of videos on my other Ender 3, the original Ender 3. I did a bunch of upgrades on that one, which I've shown. Check those videos out down there. Subscribe if you're not already subscribed. Patreon support link over there if you want to help support the channel. And I'll catch you later. Bye.